09 paper 1 then. 5a. The diagram below represents a neutral atom, and there's a key word, neutral atom of a helium isotope. Write the names of the particles indicated in the boxes. Right, well in here we have the nucleus, and 2 of the particles are in the nucleus. We know already that what's contained in the nucleus are protons and neutrons, but how do we know which is which? Well, to be able to do that, we have to look at the other particles which orbit around the nucleus, and these are electrons. So the first one's an electron, and the second one's also an electron. So we have electrons around the outside. Now we still have to figure out whether the grey one or the white one is a proton and which one's a neutron. To be able to do that, we look back at the start of the question. The diagram below represents a neutral atom. That's the important key word there, the neutral. That means that there's the same number of electrons as protons in the atom. Now let's look at it. We have 2 electrons. That therefore means we need 2 protons to balance up the charge to make it overall neutral. Therefore, the white ones are protons, which means that the grey one must be a neutron. So by a process of elimination, we can work out each of them. Part B. The nucleus of an atom of an isotope of sodium, chemical symbol Na, is represented as shown below. What is the mass number of this nucleus? Well, we must always remember that it's top heavy, so the mass is at the top, so it's 24. Also, a key way to remember it is that apart from hydrogen, the mass number will always be greater than the atomic number, so pick the bigger one. So the top one or the bigger one. Part 2. What information does the mass number give us? It gives us the total number of protons and neutrons. Now you must have the word total there in your answer, or alternatively you could say the number of protons plus the number of neutrons. So either way you must make it clear that it's the sum of them. Part 3. Sodium has several isotopes. In terms of the particles that make up the nucleus, what do they all have in common? Well, they're all sodium, and the chemical properties of the element are determined by the atomic number and the number of electrons and protons. So they have the same number of protons. They also have the same number of electrons, and it's the electrons that determine the chemical properties of it. However, the question asked us in terms of the particles that make up the nucleus, what do they all have in common? In physics, we're more interested in what's happening with the nucleus, especially in terms of radioactivity. So we're interested in protons and neutrons. Part 4. This isotope of sodium is unstable and disintegrates by beta decay. Complete the decay equation for this by writing the appropriate numbers and symbol in the empty boxes. So it disintegrates by beta decay. So let's start first of all. It's sodium, becomes magnesium, and throws out a beta particle. So let's start with beta. The mass of beta is 0, and its charge is -1. So this is a symbol for beta that we use in all nuclear equations, and you must learn this symbol along with the equivalent symbols of alpha and gamma. Now, to work out the numbers that we put in here for magnesium, we must remember it's an equation. So the mass number on the left must be equal to the total mass number on the right. On the left we have 24, so something plus 0 will give us 24. Therefore, the mass number of magnesium is 24. The same applies to the atomic numbers. The total atomic number on the left must equal the total atomic number on the right. If we have 11 on the left, the atomic number for magnesium must be 12, because 12 minus 1 gives us 11.